In this next video, we're going to continue with solving systems, but this time we're going to use the substitution method. So when you're using the substitution method, your first step is to look for either x equals or y equals in the equation. Because if x or y is already solved for, then you can plug whatever equals into x or y in the other equation. So for example, we look at example number 1. The first equation starts with y equals. So since we see y equals and y equals x plus 1, I can plug x plus 1 into the y in the other equation. So my new step is I'm going to replace the y in the other equation with the x plus 1. So my equation becomes 6x plus 7, and instead of y, I'm going to plug in x plus 1 in parentheses. Now that I have an equation with just one letter, like there's only an x here, I can solve for the variable x. So I have 6x, here I'm going to distribute my 7. And now I can combine like terms, so 6x plus 7x becomes 13x plus 7. And I can continue solving for x. My next step would be to divide 13, so x equals 1. So now that I have one of my solutions, I move to the next step. So I've solved for my variable. Now my step 4 tells me to plug this answer back into an original equation to solve for the other variable. So now that I know that x is equal to 1, I can plug that into x in the original equation, the one that had y equals. So I can plug that into this x up here. So let's go ahead and do that. So for x equals 1, I'm going to plug that into this x. So instead of x plus 1, it becomes 1 plus 1. So y is equal to 2. And now that I have my two answers for x and y, I can write my answer as an ordered pair. So remember, when you have ordered pairs, you always put x first, then y. So my x was 1 and my y was 2. You could take this a step further and check your answer. Remember, your solution is going to be the point that satisfies both equations. So what I mean by that is if I were to plug in 1 for x and 2 for y in my two equations, they would come out true. So let's do a little check here just so you can see that. So I have y equals x plus 1. And if I plug in 2 for y and 1 for x, this equation is true. My other equation was 6x plus 7y equals 20. I'm going to plug in 1 for x and 2 for y. And if I work this out, I end up getting 20 on both sides of the equation, which means it satisfies that one as well. So when you're checking if the ordered pair makes both equations true, then it's the solution to the system. But it has to work for both equations. Example 2, we're going to do our first step again. So our first step is to check which one has x equals or y equals. So here I see an equation that starts with x equals. So I can replace what x equals with x in the other equation. So I'm going to put negative 2y minus 8 into this x over here. So it becomes 2 times negative 2y minus 8 plus 3y equals negative 14. So now I have an equation that only has the letter y in it, and I can solve for y. So let's go ahead and distribute. I get negative 4y minus 16 plus 3y equals negative 14. Now I can combine like terms. Negative 4y plus 3y is negative 1y. I get negative 1y equals 2, and if I divide by negative 1, I get negative 2 as my answer for y. Now that I have my answer for y, I can replace y with negative 2 in the original equation. So that original one that I used, the x equals, I can replace the y that's here with negative 2 now. So instead of x equals negative 2y minus 8, I'm going to do that down here. I have x equals negative 2. For y, I'm going to plug in negative 2 minus 8. Now if I work it out, negative 2 times negative 2 is 4. and 4 minus 8 equals negative 4. So my solution, if I write it as an ordered pair, would be negative 4, negative 2, because those were my answers for x and y. So main thing that you have to do is look for x or y equals by itself. Then you plug whatever it's equal to into that variable in the other equation.